offline.
Absolutely.
Yep.
Okay, Steve, back to you.
Okay. And you can see my screen right now?
Absolutely.
Okay. So let's go on to the next topic here, which is going to be there we go, compound information. In the compound information window, what we're going to be doing here, this appears in the lower left-hand corner by default. Right now, icons or information that's available in the compound information. I have the icon for the target quantifier, target qualifiers, and the target spectrum that's involved there as well. These are the three windows for the targets, and then I can also view the internal standard windows associated with that particular target compound if I'm using a method. The compound information window gives us the graphic display that allows us to look at one compound in one sample at a time. Compound information has a toolbar associated with it. The icons over to the left are the icons that allows us to zooming, peak scaling, auto scaling, X and Y axis, whatever our preference is in looking at those. We also have a peak to fitting type thing where we'll always make that peak regardless of the concentration to full scale in the window. I also have the same arrows that we saw in the batch table. The green up and down arrows will allow me to go from sample to sample. The blue left and right arrows allow me to go to compound, and these are also right there in the compound information window. This is displaying and hiding the target qualifier spectra internal standard, and we saw this on the previous slide. Then in addition to that, manual integration. If I turn on manual integration, all my manual integration icons will become active. I've turned on manual integration in this slide, and basically what's happening here is I get the tick marks in the compound information window. I can click and drag and move these around. In addition to that, I now have the ability, these other icons that are available to us. Once I've manually integrated once I've turned manual integration on, essentially what winds up happening here is the qualifiers are no longer overlaid. We get a separate window for each of the target, qualifier 1, qualifier 2 in this example, and I can manually integrate these individual qualifiers. Excuse me. The manual integration toolbar. I have some very nice icons here that allow me to enable the manual integration, turn it on first. Then once that's turned on, if I do manual integration and I'm trying to get it manually integrated, I'm struggling with that, I can always hit the clear manual integration toolbar or tool icon, and that will bring me back to the integrated results. So once you start manually integrating, and if you don't like your manual integration, you can always come back and clear that manual integration. Also, in many instances, there may be a peak that has been misidentified or that's below our limit of detection. And basically what I would do with that peak would be to zero that peak out. Then I also have some additional icons that allow me to merge peak right, peak left. I also have the splitting peaks. If I have split peaks, or closely eluding peaks, I can split those out. I can also snap baselines and drop the baselines. These last four, merging left and right, split peak left and right, snap baseline, drop baselines, can give you very reproducible results when you start manually integrating. So you get, essentially good manual integrations at that point. Okay, in addition to that, I have another tool that's available in my compound information windows for peak annotations. Okay, let's take an example of this. Say I'm in a controlled environment, a compliant type environment, and anytime I manually integrate a peak, I have to put a justification down for why I manually integrated that peak. Well, if I had to do that, the first thing I'm going to need to do is go to my Tools menu items, Add-ins, and then I'm going to turn on the peak annotation. Peak annotation then will give me a series of more icons on my toolbar there. And these are predefined icons. NI, the peak was not integrated at all by the computer software. Okay, these are just the justifications or reasons that we put in. Each of these reasons can be easily modified. Okay, there is a file in the C program files, Agilent, MassHunter, peakannotations.xml. This file is essentially just what we were reading in the previous slide. We can change these letter designations, ID, NI, right? Display text, NI, we can change it. We can also change the text that's associated with that icon. In other words, what peak annotation can be put in our batch table. Word of caution here, if we're going to go in and edit any configuration files, always make a backup of that configuration file first. Then once I have user annotation, peak annotation in there activated and I'm using it, what winds up happening is I need to put that column in. I right-click in my batch table, go to the compound method, select user annotation. I get this new column, which now has my user annotation abbreviations in there. In addition to this, if you'll notice over to the right, the MI column, manual integration column, is checked for all the compounds that I've manually integrated in that case. And here's the user annotation that I selected for those. In addition to this, I also have some more parameters that are available to me in the compound information window. If I right-click to bring up the context menu, I can change the integration parameters for just this compound, just in this sample. I can modify those parameters. I also have the ability to restore the integration parameters from the context menu. If you remember, we also had the icon right up here to restore the manual integration parameters again. We had a question last week about with these integration parameters. Can I change them here and apply it to the entire method? The answer to that is no. If I wanted to develop integration parameters based on my samples, what I would do in this case would be highlight a representative sample in my batch table, go to the method editor, and then develop integration parameters. Remember, in method editor, we could see the compound information window. We can bring that up if we want to look at it, and develop integration parameters, and then apply it to that compound. In the context menu here, in compound information window in the batch at a glance view, these integration parameters only change this compound in this sample. Then I also have a whole bunch of other properties in the compound information windows that allows me to change the display. I can change the fill colors that are involved. I can change the peak labels that I have that I put on my compound information window. Right now it's set just for retention time. I could put name, calculated concentration, areas, heights, and so forth right down the list. And then I also have some titles that I can change, the ion polarity, collision energies. These are more related to their triple quad and or TOF, QTOF type data. I can also put the compound name and sample names in those titles as well. And in addition to this, I can change colors. I can turn grid lines on and off and so forth. We can also show the reference retention time and the recognition window here. We'll have a little bit more discussion on these two a little bit later. And on compound information is divided into two tabs. On the second tab, I can also change and other parameters. For example, the qualifiers. By default, the qualifier and the target ion are normalized in the compound information window. being an old-time chemist, I do not like that. I'd like to see the ratio of my qualifier, so I generally recommend unchecking that. In addition to that, in the compound information window, I often like to see the uncertainty band, so I will display that just to make sure that my qualifier is within a specified window in relation or ratioed out to the target ion. And then I have a whole bunch of other parameters for MS type data that we would see with the triple quad or the QTOF. And then I can look at or set these up as well, whether I want to watch those or not. The match scores, we'll talk about a little bit later what those are. The reference pattern spectrum is related to high-resolution data where we have isotopic abundance, isotopic grouping, and isotopic spacing. That's available with high-resolution type data. And also, calculate signal-to-noise. Signal-to-noise, we have 5 algorithms that are available: peak-to-peak, peak-to-peak with drift, ASTM, RMS, and then auto-RMS. If you want to know which algorithm to use, if it's not specified, I recommend just going to the online help. The noise regions that we have can also be automatically determined by the algorithm, where we'll pick the lowest noise, or we can have those predetermined. The signal-to-noise is typically used the signal has to be above a certain signal-to-noise to be considered a positive type signal. Okay. The noise regions can be displayed under our Properties context menu item in the Compound Information window, Compound Information, Baseline Calculation Points. If I check this box, I see in this example I have 2 noise regions that were selected by the algorithm that are displayed here in the Compound Information window. Okay, Howard, let's grab another demo here and let's start writing some questions in the chat for us, and then we'll take a look in the next section at calibration curve and curve fit assistant.
Okay, that sounds good. So here we are back in our table. Let's look at the compound information window. All right, so again, by default, it's going to come up with just the our main compound down here. Again, we can start adding windows here. So there's our qualifier. If we hover over this, we can see what we're going to do. Spectrum, which even for MRM obviously is a little on the simple side, but it is kind of nice that it does show our target ion that we did MS on, and it shows then color-coded down here are the qualifiers and quantifiers, so it can be useful. We can also then enable the internal standard, and then so we can get a lot of information, and again, these will all kind of shift around then as we click through different compounds, okay, and different samples in this case. And again, it's kind of a kind of like this layout for moving around between different compounds and samples. Again, we've got a kind of an abbreviated browsing capability here. Again, green arrows browse us through the samples, and you can see the highlight bar moving in the upper batch table, and our blue arrow moves us through compounds, and again, you can see it highlighting in our batch table as we cycle through the different compounds. Showing some of the properties of this window, I'm kind of with Steve on liking, at least it's good to have the option that we can see the qualifiers either as normalized or as they really are in relation to the quantifier ion. So I like that view to the old style view there, if you will. So if we go into properties, and there's a lot of things you can adjust here. Feel free to dig into all this. There's always your Lifeline here, the default button. If you get too far gone, change too many things, and you can always click that. A lot of windows in MassHunter have a default button, so I'll always be aware of that. But we've got 2 tabs here, so some of the information is over here. You notice we've got a lot of the general, chromatogram, retention time, and then over here in our compound information, here's our qualifier. So we can turn off the normalization, and like I said, just hit apply and see what kind of difference that makes. So that's a little things how things would look a little more naturally if we were comparing those 2 to each other. Again, also the uncertainty band's a nice little visual cue there to help in checking to make sure that everything's where you expect it to be. So that's a nice little feature, and that works whether you normalize them or not. So you don't have to, you don't necessarily have to have it normalized. Again, just complete just a preference, whatever works best for you and your group. But it's always good to have some options there, and we can say OK at this point. And again, we talked a little about manual integration. Again, that's real straightforward, just like in most programs, click, drag, you can move things around, okay? Notice once I do start to do manual integration, then I do have the option of selecting the little canned comments we have here, okay? But if you don't do any manual integration, then there's no option for doing these, okay? And again, we can always, again, as with a lot of things, there's clears, there's defaults, there's ways to get back to our the original integration, and we can get out of the manual integration mode. And then once we do that, we go back to our normal view. Another thing that Steve mentioned, and a lot of customers like to look at, understandably, is our signal to noise. And we can add that up here, again, in the columns. In fact, let's take out the area, and why don't we replace that with signal to noise here. We just scroll down through, and again, I'll move it over by the retention time there. Okay, and so now we've got our signal noise column for each compound here, you can see. Okay. And again, the default method, it goes to an RMS type signal noise calculation with an auto noise region selection. If we want to see that, then again, the last thing we can look at here, baseline calculation points. So if we enable those, then now we can see highlighted, at least in my case, in red. Again, that's the default color. We can see what baseline points were used for that signal to noise calculation, and the ones that were picked by this particular method. Okay, so that's kind of a nice little tour of the compound information region in the batch table.
Okay, and I do have some questions, not all on the batch table, but from some of the earlier comments as well. When I exclude a calibrant injection by clicking on a dot in the cal curve graph, how do I make it show in the exported Excel table that this calibrant injection is not used? I wasn't sure if you could show that right here or another section of the software.
Very, very interesting question. Question there. Can we show it in the batch table being exported?
Yeah,
I am going to have to work on that one as well, Lindsay. Very, very good question.
That's good. We got lots of good questions.
The calibration curve, right? We have 5 levels used here, 5 points used. The question then would be, is this variable available in the batch table somewhere? The 5 points used, 5-point curve there. I'm going to have to look into that a little bit more. Off the top of my head, I can't remember.
Yeah, and I think that's kind of linked to the other question about, can we show, when we turn off one of those, if kind of information. I mean, it would certainly be available in a report if you're, including the calibration curve in the report. But no, obviously it would be, there could be an advantage to having it just in that Excel export table, because that's a nice, quick, easy thing to get. But yeah, we can definitely dig into that and see what we can find for that.
Okay. The QCs, oh, by the way, Howard, did I cut you off? Did you have anything else to show before
Nope.
I jump into more questions? Okay, great. Do QCs participate in or influence the curve? So do QCs participate in or influence the curve?
The answer to that is no. Your QC and CC is a separate level on the curve, but it is not used for determining the curve itself. Okay, they are separate points on the curve, but they are not used. Unless, of course, as we're showing here in this example, there's an L2 level that's the same concentration as the QC, right? In this case, the cal labeled in the batch table, L2 becomes the point on the curve. The QC L2 becomes another point that is just being displayed in the calibration curve, so you can visually check. It was not used in determination of that curve. This is also illustrated right above there where it says 5 levels used. That's the L1 through the L5 in the batch table. And then we have 2 QCs, L2 and L4 in this case.
Okay, and this, I think you may have mentioned this, but I'll ask it here. How is QC different from CC in calibration curve?
QC and CCs have different application or different definitions depending upon the application method that you're using. For example, in EPA methodology, a CC is a continuing cal. What we can do in the environmental type applications is I can generate a 5-point curve today, right? I'm doing GCMS. It takes me 30, 45 minutes for a run, an hour for a run, right? I don't want to have to spend that much time every day running that curve. So what I could do there is take yesterday's calibration curve. I run a CC. If that CC follows a certain criteria, which I could set, then I can use yesterday's calibration curve, the response factors from yesterday's calibration curve, in today's work. A QC, on the other hand, is just a quality control. Typically, QCs would be run periodically during a large batch to make sure that the curve is still valid. Remember, as we run samples, our source is getting dirty. Response may fall off in there. We may get contamination or other extraneous problems developing. So periodically, when we're running large number of samples, we may want to run a QC to make sure that QC falls in our calibration curve within a certain predefined criteria. Otherwise, that cal curve may become invalid at that point. So we'd have to, again, recalibrate our system, run our cals again.
Okay, thank you. Let's check the phone lines. Alan, has anybody pressed *1?
No questions over the phone lines at this time.
Okay, a couple more questions here, and then we'll continue. This one user has an older version of MassHunter, B.07, which runs on ATM mode. Can they customize calculations based on what they need?
Customized calculation was really a new field that was introduced in Quant B.08. Okay, so that would not be available in the B.0700. In this case, I would probably either recommend upgrading the software to the B.08, or the possibility, again, is to use the export the table and then use export the Excel table and then use Excel macros for that customized calculation.
And just quickly, what is the path for upgrading? Do they just contact their informatics specialist, or is there
Their local account manager? Just contact them, say you'd like to upgrade, and they can send you a quote for the upgrading of the software.
Okay, great. And the default noise is Y. Is the default noise set at X5 times 5, I assume?
Okay. What that is just a default value. Okay. What we have is a multiplier. If we go into Method Edit and we bring up the signal to noise,
see if I can get there.
Advanced tasks. Yeah, go ahead, Howard.
Yep, sure.
And then
go ahead.
Noise.
Yep.
When we come up here, we have a noise multiplier that we would apply to the noise that the system finds of 5. Why is it? Really, if we wanted to calculate true signal to noise, probably what we would do would be to make that a 1 and essentially take whatever raw noise factor. It's just a variable that was put in there by default. Okay, and in this example, analyze that batch first, and then we have different noise calculations or noise values right now. And did everyone just see what Howard just did there? A little feature that we really didn't mention was he auto-fit the columns.
Yep, that's a nice one, especially when you're shuffling around and numbers have changed as some of these got bigger since we obviously lowered our noise, or the noise used for the calculation was lowered. So yeah, auto-fit is again another nice little tool there for making it easier to see things.
Okay, and one last question, and then we'll continue. When you modify the normalized or uncertainty bands for one particular compound on one particular sample, is that similar to the integration parameters where it only applies to that single sample and compound that are being modified, or does it modify it across the board?
Okay. In order to modify the uncertainty band, that's a method editor parameter. That will apply to all samples for that particular compound. Howard, right now if we go into method edit, and if we bring up qualifier setup, okay, what we have here is the uncertainty. Right now it's set to 20% relative to what the ratio of the response of the target ion. This is kind of an industry standard that has evolved over quite a few years. Now, in certain cases, it may be you may need tighter criteria. Other cases, you can widen that uncertainty band and accept more. Remember, here what we're doing is targeted compound analysis is really what Quant's doing. We have a retention time. First, confidence that I find my peak in the retention time. Second thing would be that I have my target ion there. Then my qualifiers have to be found and have to be within this specified 20% relative uncertainty as ratioed out to the quant ion. And then in addition to that, the last criteria, which we're going to cover in the global settings section, is the correlation window. If these peaks, okay, our target ion and our qualifiers are all related, the extracted ion chromatogram that we're looking at in the compound information window, if we were to overlay these ions, should essentially have the same apex peak, integrated apex, and they should also have pretty much the same peak shape. If that peak shape changes, then there's possibilities that we have a matrix impurity involved in there, and we would need to investigate that particular compound more. Is it positive, first of all? Is it really there? And these are the targeted analysis is the criteria that we use. As we add more and more of these features or criteria to it, we become more and more confident that we're indeed looking at the peak that I think I'm looking at or I should be looking at in that retention time range. Okay, do we have any other questions, Lindsay?
The only other one I have is regarding the SDK kit. Is that available for users, free for users?
That is available, again, in Quant B.08, okay, the software development kit, SDK. and that's available in Quant B.08. It installs automatically, and it comes with Quant B.08.
Okay, thank you. That is